Okay, so this is the 2024 Higher Level Maths Leaving Cert Paper 2, question 3. ABCD is a parallelogram. AB is 10, BC is 13, and the angle ABC is 110. Let's see, find the area of ABCD correct to the nearest centimeter. Okay, so to draw this, it would look maybe something like this. Let's take this as A, B, C, and D. This is 13 centimeters here. BC is 13 centimeters. AB is 10 centimeters. And the angle ABC is 110 degrees. We've got to work out the area. There's a couple of ways of doing this. Probably the easiest way of doing it is to divide the parallelogram in two. So you've got two congruent triangles. So we just have to find the area of this triangle here and then double it. So let's do that. To find the area of that triangle, we're just going to use half AB sine C. So to find the total area, it's going to double that. So it's going to be twice half 10 times 13 and then sine 110 degrees. So really that's just all calculator work. When you do that, you get to the nearest centimeter 122 centimeters squared. Now the other way of doing that is possibly to have a look at this here. So you have something like this, which is 110 degrees. And you could have a look at making a triangle here, right angle triangle. We know that this is 10 here. So we know that this here is going to be 70 degrees. So you could find the height here by just doing sine 70 degrees is equal to, let's call it x, or we'll call it h for height, over 10. So therefore the height is 10 sine 70 degrees. So the height, this is the height of the parallelogram. All you got to do is multiply that by the width, and that gives you the area. So the area then would just be 10 sine 70 degrees times 13. And you can see that's exactly, and you're also going to get 122 centimeters squared here. But this here is exactly the same as this up here, because 2 times a half just gives you 1, and you're left with 10 times 13 sine 110. And because 110 is in the second quadrant, if you like, and sine is positive in the second quadrant, you're going to get the same result for sine 70 and sine 110. But anyway, either way is fine. Let's move on to part B. X is an angle with x being 0 to 360 degrees. The cos of 2x is root 3 over 2. Find all the possible values for x. Well, you should spot that root 3 over 2 is the cos or the sine of some special angle, so you can look up your tables to find what that is. But let's just draw a quick sketch here. We are looking for cos of some angle to be root 3 over 2, and it's going to be positive. So where is cos positive? Well, cos is positive in the first quadrant, so our first angle is going to be there, and it's also positive in the fourth quadrant. So our second angle is going to be this angle here. Now I'm just going to call these two angles, this one here I'm going to call alpha, and I'm going to call this angle here alpha as well. Alpha is going to be my reference angle. So what we're going to do then is just work out what alpha is. What we need to do is look at cos inverse root 3 over 2, or just look root 3 over 2 up in your tables, and you'll see that it is 30 degrees. The cos of 30 degrees will give us root 3 over 2. So these two angles here, root 3 over 2, which means then that 2x, our actual angle 2x, or they write it like this, 2x is going to be equal to 30 degrees. It can be equal to 360 minus 30, which is 330 degrees. Can also be equal to 30 degrees plus 360. So that's 390 degrees. So you can also take 330 degrees and add another 360 degrees. So that'll bring you up to 690 degrees. So I'm just going around the circle over and over again. We'll do another one, let's say 750. So if you take 390, add another 360, that'll bring you up as far as 750 degrees, and so on. You can keep on going around and around the circles. So if 2x is equal to these angles here, that just means our angle x then is going to be half of all of these. So it's going to be 15 degrees. Let's see, this is going to be 165 degrees. This one here is going to be 195 degrees. This one here is going to be 345 degrees. And this one here is going to be 375 degrees. But remember up here it said that x has to be between 0 and 360 degrees. So what we're going to do is get rid of this one because that's outside the range, and these are our answers here. And that's it really. It's going to be 15 degrees, x is going to be 15 degrees, 165 degrees, 195 degrees, and 345 degrees. Okay, so that's it for this part of the question. Let's have a look at the next part, which is part C. So in this part of the question we have KLM, which is a triangle. Let's just draw a triangle here. So let's say K there, let's put M there and L there. So let's see, MK is 15 root 3. MK is 15 root 3, and we're looking at centimeters here. ML is 45 centimeters, and the angle KLM is 25 degrees. So in this case we don't have two sides and an enclosed angle, we have two sides and an angle outside those two sides, if you like. Work out two possible values for theta, because theta is the angle LKM. So theta is going to be this angle up here. Now we've got to work out two possible values for this. So it should kind of give you a hint here, because we have two sides and not an enclosed angle, we're going to use the sine rule, and there is the ambiguous case for the sine rule, so that will give us our two angles. So let's write down the sine rule and see what we can work out. Well, we need sine of theta over the opposite side, which is 45. That's equal to the sine of 25 degrees. That's going to be over 15 root 3. We can just cross multiply here, so we have 15 root 3 sine theta. That will just give us sine theta is equal to 45 sine 25 degrees divided by 15 root 3. Now if you work all this out on the right hand side, you get sine theta is equal to 0.7319963015. So to find theta then we would just do sine inverse of this here. But if you think about it, there are going to be two angles that have this as a sine. So one angle is going to be in the first quadrant, and because sine is positive in the second quadrant, we're going to have another angle here. So this will be one angle, this will be the other angle here. So when we do sine inverse, 0.7319963015, we get an angle of 47.05401, and so on. So that angle there is going to be the angle in the first quadrant. It's also going to be this angle here. It can be a reference angle here as well. So it's these two angles here. So this is going to be one answer, if you like, this one here. The other answer for theta is going to be 180 degrees minus this angle here. So let's work that out. So our answers are theta is equal to, we have to do this to the nearest degree, so it's going to be 47 degrees, and 180 degrees minus 47.05401. It's going to be that there. So when you do that, you get 133 degrees. So there are two answers, these two here. So theta can be 47 degrees or it can be 133 degrees. That's the ambiguous case for the sine rule. What you would usually do as well is just check to make sure that the second angle will actually work. So I'm just going to do a quick check here. So we know that one of the angles in our triangle is 25 degrees. So you would take the 133 degrees, which is one of our answers here, and you would add that to 25 degrees. If that's greater than 180 degrees, then you know this 133 couldn't possibly be one of the angles. But I think we're going to be fine here. It's 133 plus 25, that is 158, which is less than 180 degrees. So it is possible to have an angle of 133 degrees in our triangle. Okay, so that's fine. There are two answers, and that's it for this question.